Hi folks, welcome back to Physics with Captain Rod. I'm making this video to help you out with number 7 in your Unit 2 homework. So, alright, first of all, what this is about. We've got this elevator here. Ooh, oops. And the entire system potentially is accelerating up. This first case here is talking about the system accelerating this way at 3 meters per second per second. So this is all about how to draw free body diagrams and write appropriate Newton second law equations. So it's important to realize there's two different ropes in this problem. There's one here and there's one here. So there's two different tensions that we're going to be looking for. Now, which one we find depends on which free body we draw. So what you're going to want to do here, right, is maybe start by drawing a free body of this as a system. The rock, and pretty well that's it. And it should have two force vectors on it. It'll have its weight down, which you'll calculate using its mass, and then that rope is pulling up on that rock. And that's it. There's nothing else in contact with that rock. So at that point, you can write a Newton's second law equation. Sum of all forces equals mass times acceleration. And this thing's accelerating up. So when you write that force equation, I would write it with up as positive. Right? All right, next, let's talk about the elevator accelerating down at 3 meters per second per second. So now, when you write your force equation, again, you draw a free body of the same rock, except now, because the acceleration is down, I would write, when you write your Newton's second law equation, define down as positive. Right? That'll give you a slightly different equation, and it'll give you a different value for the tension. You could also define up as positive, but just remember that when you write your Newton's second law equation, your acceleration is down. You would put a negative number in for the acceleration. All right. Oh, I guess I haven't talked about how to find the second rope yet. All right, to find the rope, to find the tension in the second rope, that's this one. And what you're going to want to do is you need to draw a free body that has that tension in it. There's two possible free bodies we could draw. Here's one possible free body. Now, if we draw a free body of that part of the system, there's going to be two tensions. The tension in that upper rope will be up, but the tension in that lower rope, which you found previously, would be down. And that will work just fine. Write a Newton's second law equation. And solve it. The other thing you can do is define your system like this. And the reason for doing that, what's kind of nice is this rope right here, the tension in that rope becomes an internal force and won't show up in that free body. You'll just have one single force vector up for this rope and a pair of mg's down, one for each of those masses. Now you can also just draw one weight vector and use the total mass of the system. So that should get you through number 7. I guess I'll discuss some of these other ones down here. Everything that I talked about applies to these as well, as far as how to draw the free bodies. And just ask yourself now, if the elevator is moving down at constant velocity, what does that mean for the acceleration? And that should get you through that problem. So I hope that this video helps. Have a great day.